Okay, question number 8. We've got a graph here which has a domain which is negative. So this continues on and on and on and on and on. And this is the rule. Find the general solutions for f of x equaling 0. So I'm looking for these answers. And there will be an infinite number of them. And they're only negative answers. Okay, so I want e to the x sine of x equaling 0. E to the x can never equal 0, so it's when sine of x equals 0, and that will be at x equals 0 minus pi minus 2 pi minus 3 pi. Do I include 0? I do include 0. So x is going to equal n pi, where n is an element of all integers but negative, including 0. And find the solution to the derivative equaling 0. So I have e to the x sine of x, and I want d dx of it. So I take the derivative and it's a product rule question. U equals e to the x, u dash equals e to the x, v equals the sine of x, v dash equals the cos of x. Therefore I've got d dx, sorry, f dash of x equals e to the x cos of x plus e to the x sine of x, which is e to the x cos of x plus sine of x. And I want to set that equal to 0 because I'm looking for the maximum. E to the x is never 0. Therefore, cos of x plus sine of x equals 0. Cos of x equals negative sine of x, which will be in quadrant 2 and quadrant 3. So 3 pi on 4 and 5 pi on 4. However, I want negative answers only. So therefore I want minus pi on 4 and minus 3 pi on 4. They're my two solutions in those. So I want x to equal minus pi on 4 plus 2 pi n and minus 3 pi on 4 plus 2 pi n, where n is an element of negative integers. Okay, show that the derivative of this equals that. Okay, so I've got a product. So it's going to be the e to the x, so the derivative of e to the x times the sine of x, plus e to the x times the derivative of this, which is cos of x, and then minus, I've got e to the x cos of x, and then the derivative of this will be minus e to the x sine of x, and that's going to be the e to the x sine of x plus cos of x minus cos of x minus minus plus sine of x equals e to the x times 2 times the sine of x, which is 2 e to the x sine of x, and that equals the right-hand side, so that's correct. Hence, so I've got to use that previous answer, find the area bound by the graph of f and minus pi to 0. So I'm looking for this, and it's negative. So the area is going to be the integral from 0 to minus pi of e to the x sine of x dx. And I've got a recognition question here where I know from the previous question that d dx of e to the x sine of x minus e to the x cos of x equaled 2e to the x sine of x. Therefore, e to the x sine of x minus e to the x cos of x equals the integral of 2e to the x sine of x dx, which means the integral from e to the x sine of x dx is equal to a half of e to the x sine of x minus e to the x cos of x. Therefore, this is going to equal, from 0 to minus pi, a half e to the x sine of x minus e to the x cos of x, which will be minus a half. So e to the minus pi sine of minus pi minus e to the minus pi cos of minus pi minus e to the 0 sine of 0 plus e to the 0 cos of 0. Sine of minus pi is 0. Sine of 0 is 0. So minus e to the minus pi times minus 1 plus 1 times 1. A half of e to the minus pi plus 1. And lastly, consider the function is a continuous random variable. Okay, so this is the same as question 8, except I have this multiplier. The negative turns it to there, and this multiplier makes the area equal to 1. If xm is the value of x for which g is a maximum value, okay, so g is a maximum value will be here, and I know from my answer in 8b that that will be at minus pi on 4, because that was the value where the derivative equaled 0. So now that I've swapped it around and turned it by a multiplier, that's going to be at minus pi on 4. So what am I looking for? I'm looking for the integral from, I want as a maximum value, so I want less than, so minus pi to minus pi on 4 of negative 2e to the pi over 1 plus e to the pi e to the x sine of x dx. So I've got negative 2 e to the pi over 1 plus e to the pi times this integral, and I'm going to call this f of x, because this is what I had originally. So 2 marks for this. Okay. So I'm going to have minus 2 e to the pi over 1 plus e to the pi times from minus pi to minus pi on 4, and I can use my integration by recognition. It's going to be this expression here. A half e to the x sine minus cos, sine of x minus cos of x. So times, I've got e to the minus pi on 4 times the sine of minus pi on 4 minus e to the minus pi on 4 cos of minus pi on 4. Putting in the negative, I'm going to minus e to the minus pi sine of minus pi, then minus minus plus e to the minus pi cos of minus pi. That goes to 0. I'm now going to have minus e to the pi over 1 plus e to the pi. I've got e to the minus pi on 4 times negative root 2 on 2 minus e to the minus pi on 4 times positive root 2 on 2 minus e to the minus pi, because that's equal to negative 1, therefore that will turn it to a negative. Minus e to the pi over e1 plus e to the pi over e to the minus pi on 4 I've got negative root 2 on 2 plus negative root 2 on 2 is negative root 2 minus e to the minus pi. So this is all over 1 plus e to the pi. This times this gives me root 2. E to the pi times e to the minus pi on 4 is e to the 3 pi on 4. A negative and a negative is a positive. E to the pi times e to the minus pi is e to the 0, which is 1. And that's going to be my final answer.